We are looking at another topic I assume you're all familiar with. Otherwise, it is time to study that. In any case, make sure that you look at these video completely, and whatever you don't understand, read up. So we are going to talk about exception processing. Exceptions are situations that occur in a program and can cause an issue. So let's see what kinds of exceptions we can have in a Java program. There are three types of exceptions. One is the result of bugs, one kind. For example, you may have a null pointer trying to access an object, and that is a bug. Or you can have a bad array index. For example, you might try to access an array with an index value of -1, in which case you will get array index out of bounds exception. In those cases, you should just fix your code. It is a bug. You should debug your code and ensure that your bugs are corrected. The second kind of exceptions are things you can't do much about. For example, there is a memory error, or you try to read from disk and there is a problem with the connection. Those kinds of things you can't do much about. Those are hardware issues. Somebody has to fix them. Usually you ignore them. That is the most recommended action. Then there are these third kinds of exceptions, which are not programming errors, but those are situations that you can anticipate. For example, your program might need to read a file, and it is quite possible that when the user runs the program, the file is not there. So a file being absent on disk is something you can anticipate, and those are exceptions that you need to fix, you need to anticipate, and you need to have some form of handling it. So let's see this. Let's look at this piece of code. We are opening a file. Don't worry too much about the intricacies of the code. Actually, we will look at similar code even next week when we talk about serialization. So don't worry too much about what these things mean. That is not important here. We are trying to open a file called data and try to use it, try to read it using this object called input, object reference input. The object is on the right-hand side, of course. And we try to read the object that is in this file data using this reference. So input.read object attempts to read stuff from the file. And once that data is obtained, we return the data. So this is obviously in some method. Everything has to be in some method. At least most of the code in a Java program is in a method, right? So there are a couple of issues with this code. One is that when you try to open a file, in this case, the file name is data, it may not be present on disk. So the file may not be there, or it could be, there could be some issues related to its opening. That is called an IO exception. So how do I know that? From documentation, that's it. When you look at this class file input stream and look at its constructor, we see new file input stream. That means invocation of the constructor, right? The Java documentation tells me that it can raise IO exception. That is the only way that anybody can know about exceptions. So this can cause IO exception, and this line here, which reads an object from the file data and converts, casts it, views it as a data type. Data is some type that is in the system. We don't know where it is, but let's assume that there is a class called data, and whatever we read from here is cast as data. You know about casting. You can read a character and cast it as an int. You can take an int and cast it as a character, such and such things. So you can have a double and cast it as an int, right? So this code has a couple of problems. One is the IO exception here, and the casting exception here, which is that this class is not quite castable. This object is not quite castable as this. So that is the other thing. This class is not found here. So there are a couple of issues. So to handle this, one way would be to write try and put all the code that you think can cause exceptions into one block. So this is called the try block. We write the word try, put the left and right curly brackets, put the code that contains opportunities for generating exceptions. And then after the try block is complete, put what are called the catch blocks. So you write catch, and in parentheses, you put the name of the exception. This can cause IO exception, so I put IO exception here. This is the name of the exception, which you have to find from Java documentation. There is no other way. And you give a reference here. Now look at the naming conventions for exception classes. The references are written with all the capital letters here in lowercase. So IOE are all in capitals in the class name. So you put IOE in lowercase here. And you can do whatever you want here. Essentially, you have caught the exception. You can do what you think is appropriate. So I print the stack trace, which is the sequence of method calls, and then I return null. And here I'm catching the second exception that this piece of code can throw, and that is class not found exception. And again, the capitals are picked and converted to lowercase, so I have CNFE. And I'm doing very similar stuff here. So if there is an exception thrown in this code, Java examines to see whether there is a corresponding catch block for it. And if so, it executes that catch block. And the rest of the try block is abandoned. So for example, if data is not found, this generates an IO exception control. This assignment is not even done. So file will be null. You will come here, execute this piece of code and return null. Or if this is okay, but there is an exception in the class cast, then this would be, this branch would be taken and it will do this piece of code. So this can handle an exception. That is called catching the exception. Now, exceptions can be propagated. Let's briefly see what is going on here. We have a section class here, which a section is for a certain course. This we saw in a previous lecture. That is, we have a course object here for which this is a section. This is the ID of the section, like 1, 2, 3, or whatever. So we can create a section in a couple of different ways. One is to give a course object, and then it stores the course object here. A second way would be to create a section without any parameters, and it doesn't do anything inside the body. Then I have a toString method in section, which takes the course object, gets its name, and prints the ID. Or rather returns it. ToString doesn't print, it just returns that. Now here we have the main method in this second class or third class, except2. I create a section with no parameters. So it goes here, creates a section. I have the section object in section 1. Then I call section1.toString. So it goes here, it tries to get the name from the course, but course is null. So this raises or throws the null pointer exception, and this toString execution is abandoned. So what happens is it comes back here to the main method. Since toString did not handle the null pointer exception, by the way, you shouldn't be handling null pointer exceptions. That is usually a bug. So there was no reason for me to handle it here. But in any case, the principle doesn't change. Since it is not caught here, Java immediately abandons the execution of toString and goes back to where it came from. And that was in the toString method of the toString method call here in main. And there is no try block here either. So the whole thing is abandoned. The main method is abandoned, and the program crashes at that point. So exceptions can be propagated from the method in which it occurs all the way to main. And in between, if there was a method that handled the exception through a try catch phrase, that takes care of the exception. So exceptions can be propagated. You can declare something as throwing exceptions. You can write public M1 throws some exception 1 comma some exception 2. So this is good enough for catching or taking care of exceptions within a piece of code. Or you can write public static data retrieve throws IO exception class not found exception. That also works.